Good evening to everyone. I am Dr. K. Kannan, Assistant Professor, Department of Computer Science, Dr. SNS, Rajalakshmi College of Arts and Science. So, today I am discuss about edge and fog computing. Today specific topics in discuss about the application of edge computing. First of all, I would like to introduce real-time application of edge and edge computing. There are more applications available here because of lot of application available in edge application, and particularly I put my presentation is autonomous vehicle and smart factories industry 4.0 and healthcare and smart retail and smart cities. Those are applications. First, we are detailed discuss about what is autonomous vehicles. That autonomous vehicles is nothing but some of the enables of 10 millisecond decision making of crucial for collision avoidance. Because of main purpose of this EV navigation is real time. The traffic condition, the adjustment is very important of the autonomous vehicles. The enhancing the safety and efficiency. The traffic time easily we can move for 10 milliseconds level. Easily we can avoidance from this autonomous vehicle from the traffic and the accident level. The easily we can adjustment of IoT devices we have added. So the autonomous vehicle is very important of this edge computing, the filling the data informations. Next, we discuss about what is a smart factories. The industry 4.0, the real time is predictive of maintenance of leading the average of 20% reduction in machine downtime and ensure the immediate quality of control the production line. So some on the factory level of this time easily we can maintenance of we are using two edge applications, so easy we can control for all the quality aspects and production lines, and it is using for this edge computing. Next application is healthcare. The healthcare is support for remotely we have access from the patient monitoring for via the wearable of devices. So they name the immunity detection. Easily we can anomalies of critical health alerts without the delay. So this is wearing for some devices. Easily we can indication for the health. Okay. Before the health alerts without delay. So this is one of the applications provided for edge computing. Next one is what is the smart retail. The retail is the inventory tracking, real-time inventory tracking. It is optimizing the stock levels, how to delivering the personalized of offers, the customer based the store the behavior. So the smart retail is one of the application we have using the edge computing, and smart cities is traffic time and enhance the public safety through rapidly easily we can direction from easily monitoring for all the quality of access in emergency time the response the edge computing. So some of the device providing for all the mechanism we have including the smart cities. The best example for cameras and tracking of lights and sensor, you put the sensor for all the smart cities. Easily we can control for all the managing all the peoples. The smart city is one of the application best example for the edge computing. The next one is edge devices and examples. The edge computing is one of the all the performing the network peripheral. So the source of the data generation, how to widely used for the function. They are common edge devices we have provided. The following one is IoT sensor is one of the environmental data collection, and the next one is smart cameras is one of the best example. They embedded for all the analytic of capabilities, and the local servers we have providing in local server. the mini service deployed on the site. So next one is the industrial control for all the manufacturing plants and smartphones and other mobile computing devices. The best example for this edge common devices. The specific instance of the smart security is camera that perform the onboard facial recognition, the alerting security person in real time, and manufacturing the robots and embedded for AI and immediate of defect and detection of assembly lines and preventing the costly errors. The 5G basis of stations is aggregate and process local network traffic and optimizing the data flow and are connected for users. So easily we can preventing for all the error, and 5G technologies for implemented from the edge computing and wearable health monitors, healthcare department. We are using two healthcare monitors is processing of biometric data and heart and rate and blood pressure and etc. is the alert for all the anomalies without needing the cloud intervention. So this basically we have providing for easily we can monitoring for all the devices. So this is example. So next one is an edge computing with cloud computing comparison. The comparison for the processing location. It is a near data source. The edge device is nearest data source. Example device local network. But cloud computing is centralized data centers. Remotely we can access. So very difficult to access for the centralized data processing time, and latency is very low for below 10 milliseconds and higher than 50 to 150 milliseconds plus, and bandwidth usage is minimized of upstream data is transfer and significant data raw data required for this transfer time, and the data volume handled is very small. Easily we can filter the data sets, but they handle the large data and aggregate the data sets, and best use cases of real time mission of critical local operation, but big data analytics is long term storage and global access. So those are what is the main difference between the edge and the cloud computing. Next one is edge computing purpose and application, and edge computing is representative of data processing is moving the computation easily. We can data sources of centralized cloud infrastructure rather than the centralized the cloud infrastructure. So the main purpose of locally we can access for all the data raw data from the edge computing, but cloud is nothing because of centralized access is commonly, so large data value amount we have discussed. So the edge computing we have using the low latency level and real time applications. The valuable of bandwidth is locally and reducing the data transmission over the public networks, and it is a immediate of insight of faster decision making. The UK market is computing of this robust growth and projected of annual growth, and 25% have reached 5.8 billion by 2028. So the most probably we have using the 5G networks and IoT devices is included. So easily suggesting for 75% of emerging of edge computing applications. Next one is industrial IoT and edge integration, and the predictive maintenance and quality content asset tracking. Predictive maintenance is nothing but such as is easy vibration of temperature readings and locally of edge, and prediction and potential of the 7 to 10 days advance, and quality control, which means it is a protection of all the lines. Each count is instantly of data is product is defects with milliseconds, the leading the significant of reduction of waste of approximately 15 to 70% we using the edge integrations. And next one is what is the asset tracking, and it is a process of location data from equipment and inventory, and it is provides a real-time tracking is a factory environment, and also improving overall asset utilization of efficiency of by 10 percentage. Each smart home and buildings, it is energy management and security and access control and elderly of care. Those are the smart home buildings. Next one is transportation of system and age. And transportation means autonomous vehicles and smart traffic management and fleet management. The fleet management is provide a real-time insight of vehicle diagnostics and enables of predictive maintenance and significantly reducing the roadside breakdown by the up to 20%, optimizing the fleet operational efficiency. This is the ratio of healthcare monitoring side. We are using to edge computing using the more than 75 percentage healthcare monitoring using the edge computing up to I give the mapping and 0 to 18 and it is more than 25%, 15 25 percentage we are using to healthcare monitoring in edge. And retail and inventory management is easily we can providing application real-time inventory tracking and personalized customer experience and loss prevention. Those are retail and inventory management. And manufacturing of automation of use cases of robotic control and quality assurance and process optimization of easily we can automation of use of cases in edge computing. Environmental monitoring at the edge and air quality monitoring and smart agriculture we are using to the edge computing and disaster prediction easily we can using for environmental monitoring for all the time in edge computing. Gaming and augmented reality and virtual reality for on edge platforms. The edge platform is improving the responsiveness of 50 to 100 milliseconds of input of 5 to 10 milliseconds, and it is a low latency of deliver smoother and remotely we have access for this edge platforms. And similarly augmented reality virtual reality is benefit of immense supported from this data processing time. So AR and VR environments real-time object recognition and integration interaction with the edge platform provide the without significating, and it is a more believable of engaging the virtual worlds. This is the edge in emergency of response system in future helper. The rapid incident assessment and predictive policing, crime prevention and future growth and areas. The futurely it is a 5G and artificial intelligence and Internet of Things is unlock a new market. So smart infrastructure of centralized and digital twines of complex system. Thank you.